Hello everyone, welcome back to my channel, Mambalut's Math Tutorial. Today we will be discussing all about some introductions to probability. Let's have activity 1 entitled Am I Sure? In this activity, we have this table in which we have the first column, which are the different statements, and in the second column is you have to determine the different statements if it is sure to happen, impossible, or may not happen. So, number 1, the sun is setting in the east. This is impossible to happen since the sun is setting at the west. Number 2, increase in the side of a square results in the increase of its area. Of course, this is sure to happen since any polygon in which the sides increases, so the area also increases. Number 3, tomorrow will be a bright sunny day. So we will not know what will happen tomorrow, so this is may or may not happen. Number 4, a father is younger than his son. This is impossible also because a father is always older than his son. Number 5, on tossing a coin, I will get ahead. So since you are not sure that this would be may or may not happen. Number 6, a leap year consists of 366 days. This is sure because it has really 366 days. And number 7, on throwing a die, I will get the number 6. So this is not sure, so it would be may or may not happen. Now, from this activity, let us have some different terms which are related to probability. The first one is an experiment. So what is an experiment? It is any process that can be repeated in which the results are uncertain. So, for example, if we are to flip a coin. So, in flipping a coin, you are not sure if you can get a head or a tail. Then, if we have tossing a die. So, in tossing a die, you can get a 1, 2, 3, 4, 5, or 6. Or we can have also picking a card. So, in picking a card, you can get a heart, a club, a clover, or any number. Another one is an outcome. It is a result of a probability experiment. So, example, getting a head in flipping a coin, or getting a number 3 in tossing a die, and getting a queen of hearts from a deck of cards. So, we call it the outcome. Another term is an event. It is any collection of outcomes from a probability experiment. So in probability, we have simple events or compound events. When we see simple events, it consists only one outcome. So an event may consist of one or more simple events. So if you have more simple events, we call it now the compound events. Then the events can be denoted by using capital letters such as letter E. Another one is a sample space. Sample space represented by capital letter S of a probability experiment is the collection of all possible simple events. So if you put it together, all the outcomes in the events, we call it the sample space. Or in other words, the sample space is a list of all possible outcomes of a probability experiment. For example, in flipping a coin, the sample space would be H and T, which represents the head and tail. In tossing a die, S is equal to 1, 2, 3, 4, 5, and 6. And in picking a card, you can have a heart, a king heart, queen heart, jack heart, and so on. Then all the other flowers in the card, which consist of 52 cards all in all. Now let us define what is a probability. It is the chance that an uncertain event will occur. So a probability is always between 0 and 1. So if we have this probability line, 0 would be the result if the event is impossible to happen. And it would be equal to 1 if it is sure to happen. And 0.5 if it has an even chance. These are the different symbols that we will be using in computing for the probability. We have there the probability of event A that will occur, then the probability of a red card, and the probability of getting a red card, and at the same time it is an ace card. Let us go back to our activity 1 and we will determine what is their probability. So in number 1, since it is impossible, so the probability would be 0. In number 2, since it is sure to happen, so the probability is equal to 1. In number 3, may or may not happen, so the probability is between 0 and 1. Number 4, it is impossible, so it is 0. 5 is between 0 and 1. The number 6 is sure, so the probability is 1. And on number 7, the probability is between 0 and 1. So the probability of an event has the formula of the number of favorable outcomes divided by the number of all possible outcomes. Or you can have also the P of A is equal to the number of ways A can occur divided by the total number of outcomes. We have the different properties of probabilities. Number 1, the probability of any event E, P of E, must be between 0 and 1 inclusive. So that is in symbol, the P of A is less than or equal to 1 but greater than or equal to 0. Number 2, if an event is impossible, the probability of the event is 0, of course. Number 3, if an event is a certainty, then the probability of the event is 1. And number 4, if S is equal to E sub 1, E sub 2, and so on until E sub n, then the probability of each of the event is equal to 1. Which means that if you add the probability of all the events in a sample space, the total probability is equal to 1. Let's have an example. You draw one card from a deck of cards. What's the probability that you draw a king? So the probability of getting a king is the number of kings in the deck divided by the number of cards in the deck. So the probability of getting a king is 4 since we have 4 kings in the deck of cards. Then all the number of cards in the deck are 52. So we have there 4 over 52 which can be reduced to 1 over 13. Example number 2. How about getting a diamond from a deck of cards? So how many diamonds do we have? So the P of D is the number of diamonds in the deck divided by number of cards in the deck. So there are 13 diamonds in the deck of cards. So we have there 13 over 52 which can be reduced to 1 over 4 or 1/4. Let us have more examples. Number 1. What is the probability of choosing a day in a week which starts with S? So we have only Saturday and Sunday. So we have 2. So the probability is 2 over 7 because we have 7 days in a week. Number 2. If a letter is chosen at random from the word perseverance, what is the probability that the letter chosen is E? So how many letter E in the word perseverance? So we have 4. And then how many letters do we have in the word perseverance? We have 12. So therefore the probability is 4 over 12 which can be reduced to 1/3. Number 3. A box contains 7 red, 5 orange, 4 yellow, 6 green, and 3 blue balls. Find the probability of drawing out an orange ball. So we have how many orange? We have 5. And there are how many balls inside the box? We have 25. So we have the probability is 5 over 25 which can be reduced to 1/5. Number 4. The sides of a cube are numbered 11 to 16. If you roll the cube once, what is the probability of getting a composite number? So what are the composite number between 11 to 16? We have the number 12, 14, 15, and 16. So there are 4 out of 6. So the probability would be 4 over 6, or that is equal to 2/3. Now what are compound events? As mentioned earlier, these are 2 or more simple events combined. So example, tossing 2 coins or more coins, then rolling 2 or more dice, and then picking 2 or more objects. The formula of getting the probability of compound events is the same as getting the probability of the simple events. So we have P of A is the number of ways A can occur divided by the total number of outcomes. But the total number of outcomes can be computed by using permutation or combination, which we will have an example later on. Example number 3. In flipping 3 coins, what is the probability of getting 2 heads and 1 tail? So we will be computing for P of 2H and 1T. So what are the events in the sample space of this experiment? So we have this one. If we flip 1 coin, the result is either a head or a tail. Then we flip again another coin, so from the head it can result to head or tail, and the tail also can be paired by either a head or a tail. Then let's have the flip number 3. So each of the result can have also a head or a tail. So therefore the different outcomes would be head head head, head head tail, head tail head, and so on, which are 8 all in all. So from these outcomes, since we will be counting which has 2 heads and 1 tail, so there are 3 of them which has 2 heads and 1 tail. Therefore, the probability of getting 2 heads and 1 tail is 3 over 8, since there are 8 outcomes all in all. Another example, rolling 2 dice. What is the probability of rolling back-to-back 6s? This means that we can get both 6 in rolling 2 dice. So what are the events in our sample space? We have this one, 1, 1, 1, 2, 1, 3, and so on until we get 6, 6. So there is only one event which has both 6 in result. So out of 36 outcomes, we have only one which has a back-to-back 6s. Therefore, the probability of getting 6 and 6 would be 1 over 36. Another example, what is the probability of getting both even in rolling 2 dice also? So we would be computing for the P of even and even. So from this, what are the numbers which are even? We have these events. So we have 9 events that resulted to both even numbers out from 36 events. So we have the probability of getting both even would be 9 over 36, which can be reduced further to 1/4. Now it's your turn to answer your activity sheets. I hope you learned something from our discussion today. But don't forget to like and subscribe. Thank you so much for listening. At your service, Ma'am Balot.